So for the next couple days, our next little unit, like the next quiz you take, will be just one topic. Kind of, I felt like that last quiz was hard because it had so many things on it. This next quiz is just all going to be one thing, and it's exponential equations. So today, oh yeah, I should know today's the 14th. And Tristan, we'll get to that pie here in a little bit, okay? I'll try to keep this as short as I can. Yeah, Tristan brought a pie. Celebrate, the 14th Pie Day. So. So we are today, not tomorrow, but Monday, uh, probably all of next week. I would expect a quiz over this probably 1 week from today, because it's just like I said, one big thing. Yeah, a week from today. So we're solving exponential equations, and the thing about exponential equations is that some of them are, and by the way, we refer to it as exponential when the variable's in the exponent, by the way. So like if x squared equals 16, that's not really an exponential equation. That's more of like a power equation or a quadratic equation. So we refer to an equation as exponential when the variable's part of the exponent. So if I gave you a simple exponential equation like, 5 to the power of x equals 125. This is really not what we're talking about today, but for the record, that is an exponential equation. And you don't need logarithms to solve that. You just need to know that it's 3, right? Like that's just, by now, that's probably part of our common knowledge that 5 to the third is 125. So you would just write x equals 3. What we're going to work on for the next week is exponential equations whose solutions are not readily apparent, like this. And in order to get through this, we are all at some point going to have to start using the log buttons on our calculators. That's no longer going to be something that I tried to keep that put aside. I was really hoping, and I did for the most part, I think successfully guide you away from that, which is great news. But now we're really going to need to embrace it. So the idea here is like, I don't know what power would I have to raise 4 to? And if I tried, like if I did a little like dry run, like an experiment with it, I could try. Like we all know 4 to the third is 64, and we all know 4 to the fourth is 256. So maybe I'm like, oh, let me try 4 to the sixth. And I go, oh no, that's too big. And then I go back and I go, okay, so what, 4 to the fifth? No, that's too small. So we can logically arrive at the conclusion that x has to be somewhere between 5 and 6, because 4 to the fifth, too small, 4 to the sixth is too big. So if you think about it, like if someone tasked you with finding the answer to this equation and saying, that, hey, I need it pretty accurate. I would like 4 decimal places of accuracy. And they gave you like 2 hours to do it. I don't even know if you could do that. Because I mean, it's really hard to get in there. You start guessing and say, okay, I'm going to try 5 to the power or 4 to the power of 5.312. And then it's just so eventually you pull your hair out, just trying to figure out how am I going to get 2,146? Well, this is where logarithms come in and save the day. So you will remember, and we didn't talk too much about it. There was one problem on the quiz where you'll remember from the quiz, there was one that was like, I don't know, I'll just make one up. Like if we had like log of 9 minus 3 log of 4. Do you remember what we have to do with the 3? Right. And so today we really, really come to embrace the idea that this guy is fully mobile. He says, I can be here, or I can go up here. I can go here or here or here. Like that's going to become our go-to power move for the next week, is taking a number and moving it upstairs as the power of an argument, or moving it back down in front and using it as a multiplier. So that's only works with logarithms, And so what we're going to do is we're going to go back here, and the first step to solving a logarithmic equation or an exponential equation like this is to log both sides. And it's interesting, it's the backwards of dropping the logs. You remember there were some problems where we just dropped the log on both sides. Here we're actually going to log both sides. You figure, heck, if I can drop the logs off both sides, I ought to be able to put them back in, right? So the next step of this process is going to be for us to write log of the left side equals log of the right side. And you'll notice that I'm leaving off the base. And that's because I think like 98% of the time, we're just going to use a common base 10 log, because your calculator loves base 10 logs. So we're going to go that way. So, I mean, you could use a log base 3, but I mean, I don't know. That's weird. Like your calculators, most calculators don't want logs base 3 and stuff like that. So we kind of teach it in the way that any calculator that has a log button will take it. So far what we've done is we've logged both sides. Now what that enables us to do is the power move. It allows us now to take this little guy X, and this is where you should have your moment of, oh, that's useful. It allows us to take that X and go, boop, and drop him right down into the front. And that is one of the most useful and powerful things that I will ever teach you, ever. Of all the stuff I've tried to teach you in the couple of years I've known you, that one is massive. You're telling me I can take something that's currently an exponent and I can bring it down onto the level playing field? Yep, as long as it's a log. So that's why we log both sides, is to bring that property into play. And once we bring the x down, then all we have to do now is just solve it with a little bit of basic algebra. How would I get x by itself in this equation? That's it. I would just divide both sides by log of 4. So it's at this point in time where we all need to get acquainted now with the log buttons on our calculator. So get your calculators out and let's all go find our log buttons. So you should have a button. If it's a scientific calculator, it doesn't matter if it's a Casio or a Texas Instruments or whatever. You all have a button that says LOG. Okay, so find that and hit LOG. On most of your calculators, when you type in the log, it's going to do this. It's going to put a parenthesis. I think, is that accurate? Yes. Now, that's important that you respect that because it's going to wait and it's not going to, like one of the most common errors I see is people do this. They type log and then they type in 2146 and then they go divided by log of 4. And the trouble is this parenthesis, this red one, is going to wait and stay open until you tell it to shut. So the moment you put this other red one here, then the calculator knows, okay, I'm done with the first log. That's a killer. That takes a lot of points off papers every year. So make sure, so find your log button, type in 2146, close it with a right-hand parenthesis, and then hit divided by. And then find your log button again. And again, it'll open an argument for you. And then just put in 4, close the argument, hit enter. And remember what we said going into this, we knew it was going to be 5 point something, right? It literally had to be because 4 to the 5th was too small and 4 to the 6th was too big. For the next week, our answers in this class are going to be expressed to 4 decimal places. So let me type this in just so I can see the same thing you see. Log of 2146 divided by log of 4, and I'm showing 5.5337. So we would say as an answer to this that x is approximately equal to 5.5337. And I didn't have to round the 7 up because the number after the 7 is a 1. And so that is how you solve an exponential equation. And again, I'm telling you this. I mean, this isn't going to probably help you in your everyday life when you're like 38 years old. But as far as more mathematics classes, that is a boss move to have in your back pocket. The ability to take an exponent where the variable thinks he's safe and like, yeah, you can't get me. And then you log it and pull it down. It's like, bam, that's powerful stuff. So that's how you solve an exponential equation. Now I'm going to run through some more examples with you now that we got the basics out of the way. All right, try to keep this at about 10 more minutes and then we can have some pie. That's the goal. How about this one? 11 to the power of negative 4x is equal to 34,519. I mean, really, unless you're like, you've seen Rain Man, bless you. If you've seen Rain Man, then maybe Rain Man could figure out what x has to be. But my God, I don't have a clue. So what do? We log both sides, right? Get used to saying those 3 words. Just log both sides. And so when I log the left side, I'm going to have the log of 11 to the negative 4x equal to the log of 34,519. And you'll find yourself not writing this step. Can you already feel like there's something we could have done while we logged? Yeah, you could have already moved the negative 4x down. So I'm not opposed to that in the slightest. I just thought maybe second example might be too soon. but I can take that negative 4x now and relocate him down into the front. And that's what you want. That's the entire reason we're doing what we're doing today, is to make him, because when he's an exponent, he's like, I don't know, can't work with you, bro. But if you get him down in front, basic algebra. Now to get x by itself, what do? Just divide, right? So the way this is going to go into your calculator is it's going to look like this on your calculator screen. You're going to type in log of, and then it's going to open the argument 34,519, and then you're going to close that. And then you're going to hit divided by, and I hope you're not working ahead and ignoring me. You right now have got to manually put in a parenthesis. I'll make it green so you can see it. And the reason for this is because we're going to divide by more than one thing, right? This wasn't like the last one where I could just divide by a log. Like this time, there's more. You would agree that both of these yellow things need to be divided away to free the x, correct? So that's why we open that green group, the parenthesis, and then inside of that, now we can type -4 log. And this white parenthesis that I just drew, that's not mine. That's the one the calculator gives me to say incoming log argument. And then I'm going to put into there 11. And then to make this official, how many parentheses do I need? I need 2. I need the white one here to close the log argument. And then I need the green one to like enclose all of the stuff that I want my calculator to divide by. What'd you guys get? So I'll type it in with you. So log of 34,519, close parenthesis, divided by, open parenthesis, -4. You don't need a time sign, just put log of 11, and then you go close, close, hit enter. I'm seeing -1.0894. Are you using the minus sign instead of the negative by chance? It happens a lot. You guys don't be knuckleheads. Okay, there's a minus, that's a verb for like an action to take away. And there's a negative that's like an adjective, like a descriptor. They're not the same. So, bless you. Still, so far, so good? Okay, let's head on. Let's do another one. Let's do 5 to the power of 2x minus 3 is equal to 618,921. So let's multitask this guy. Now there's going to be a set of parentheses that we desperately need here, just FYI. So let's do 2 things at once. We know we have to log both sides, but let's also take the exponent and travel him down into the front. But he needs to stay as a package deal. So we're going to need to put the 2x minus 3 in his own little cute set of parentheses. So in our next step, we're going to bring him down in front, and we're going to have 2x minus 3 times the log of 5 is equal to the log of 618,921. Was that too soon, or are we okay if can I go that fast now? Is that good? Okay, so we applied the log and brought the power down, and now the x is down on a level playing field. So there's an algebraic process to this. I'll walk you right through this. I mean, if you think about the process, the first thing that has to happen is I have to get rid of those parentheses. Option 1 is to distribute. I do not recommend that. Option 2 is just say, well, why did the parentheses even exist? Well, it's because that stupid log of 5 is over there like, hey, like if you'd go away, then I could drop my parentheses, you know? So what we're going to do first is we're going to divide both sides by the log of 5. And that's going to free up the 2x minus 3. So I'm going to show some work here that you don't necessarily need to show, but I'm just going to show you that this is what it would now look like. 2x minus 3 equals log of 618,921 divided by log of 5. And I'm leaving it on the board like this because I want to talk to you about just leaving things on your calculator screen is a good idea. Because as soon as you start taking decimals in the middle of a problem and you copy them onto your paper, you lose accuracy. Like if you take a decimal and copy it down and say, oh, that's about 5.624, you've lost accuracy. And now that affects the rest of the problem. So let's talk basic algebra. If I got us to this point, like that bottom line of what you see on the TV, let's just talk basic algebra. What would be the next step? Like go back to 8th grade. If I gave you an equation that said 2x minus 3 equals like 10, what would you do first? You'd add the 3, right? And what would you do last? So let's let our calculator do all that lifting for us, and let's never copy anything else onto our paper. So here it goes. We're all going to type in the log divided by the log, and then we'll pause there and make sure that we're all in the same spot. So we have log of 618,921, close your parentheses, divided by the log of 5, close your parentheses. At this point, go ahead and just hit enter, but pay no mind to what you see on your screen. Like I'm going to read it to you just so we can all make sure we're good, but mine says 8.2859, right? I'm not interested in that number. And I sure as heck don't want it on my paper, because again, the moment I put it on my paper, it's not going to be as good as what's in the calculator's memory right now, right? So while that sits on your calculator screen, what do we do next? Add 3. So with it on your screen, don't type anything else, just hit the plus button. And your calculator knows that you're adding to the previous answer. So just hit +3. It's important at this point that you hit enter. And now we have another number that we give no craps about, right? It's 11 and change. Don't care. Still don't care. But this next one I care because it's going to be my answer. What do we do now? Correct. So now with that on your screen, hit divided by 2 and presto, you're done. Trying to solve an equation like this without using logarithms, I can't even get my head around how almost impossible it would be. So I got 5.6430. And I know that your calculator doesn't say that, but bear in mind that it would, I wish it could say 5.6429. But the trouble is that stupid 7 bumps the 9 up to a 0, who then in turn bumps the 2 up to a 3. So for this one, assignment, quiz, whatever, we would put x is approximately 5.6430. See that effect, that rounding effect? Of course I would. Listen, I'm not going to let you get away with bad rounding. I'm not going to act like that's optional. So that's a deal. All right. I want to get through a couple more things. I just got to watch that darn clock. Dang it. I wanted to show you this. Problems like this, you just come to appreciate. And honestly, since we're using our calculators so much, it really isn't a huge deal. But do you notice, I don't know why anyone would ever answer this question the way I want, but I'm throwing it out there. Do you notice anything about this problem that might be nice? Nope. Nope. So she said, there's a 10. And you might wonder, like, why is that significant? Let's talk about it. So you know what we're going to do is we're going to log both sides, right? And we're also, while we log, we're going to drop the -6x down in front. But the awesome thing about this is, as you know from your last quiz, and you better know that that's a fact. Like that should be common knowledge to you by now, because a log with a base of 10, whose argument is 10, is redundant, right? 10 to the 1th equals 10. So if you ever in mathematics encounter the log of 10, you can make it go bye-bye. In a multiplication situation, it serves absolutely no purpose. So here's what I'm trying to tell you. When you bring this -6x down in front, it winds up dropping in front of a log of 10, which, like we just said, is 1. So the benefit to this is I can just have -6x equals the log of 34,921,084.62. Common error I see on a problem like this is people get excited about the 10 and they forget that, hey, homie, you still have to log the right side. Like, it's not like we didn't log the left. We did. It just was a nice log. It was a redundant go away log. Okay. So, and I don't want to finish this one really because I know that you know how to use the button now. So let's just move on to the next one. I wanted to show you that when the base is a 10, that's good. It'll save you just a couple button presses on your calculator. So it's nice. And finally, you will see exponential equations like this. And you probably know now based on the last one, but I'll ask it anyways. Do you see anything? There's an E. Why do we care? What kind of log could I use that would make an E go away? Yeah. And your button, your calculator has one. Guys, if you found the LOG button, look within about a quarter of an inch and you're going to find the LN button. They're neighbors. On any calculator, they're going to be neighbors. In mine, they're above and below each other. Yours, they might be, I don't know, but they're there. So this time we're not going to quote unquote log both sides. We're going to natural log both sides because the benefit, the trade-off is that if I drop the x plus 7 down in front of a natural log, what is, you know this also, because this was literally on the last quiz, what's the natural log of E? 1. It's another redundant log. It's no different than the log of 10. So I can just bring the x plus 7 down in front like this. X plus 7 equals the natural log of 859.2. Did I log the left side? You bet I did. It just was a nice one. I made it go away. Eventually, people will ask the question, well, why don't you just always use a log that matches the base? And my answer is because not all calculators like taking different bases. Your calculator is programmed, and I mean every calculator is programmed to happily take base 10 logs and base E logs. But the moment you start using like log base 4s and log base 11s on purpose, it could get messy. So we're going to stick with the beneficial ones are the 10s and the 8s. And the rest, we're just going to use a base 10 and type it in. So let's practice using our natural log button on this one, and then we'll be done. We don't have a lot of time. Got to get some pie. So we're going to all type in, obviously, natural log of 859.2 minus 7, right? So natural log 859.2, close the parentheses, hit just minus 7. We should all have on our screens negative 0.24, and I'm sorry again, 40, because the 399 has a chain reaction that keeps rounding things up. So there's more, but I'm going to leave that for Monday, so we can enjoy some of the pie that Tristan brought. So that is that. Okay. All right.